Jeremy, sorry, would you mind sharing the slides? I think it's unmanageable.
Sure.
Sorry.
Okay. Does you want to go ahead? Okay. So these are the broad areas that we can focus on our attention on. So there are different kinds of tasks when it comes to facial when it comes to detecting the face. So one is you have to detect the face first using an object detection algorithm, and then you'll have to align the face for like you'll have to figure out different features and extract certain characteristics out of it. And there is another thing called face recognition, face generation, which is what you do when you generate a face. So let's say, for example, using a generative adversarial network, for example. So what you can do is essentially generate new faces. This technique is not only improves the generation part of it, but this can also be used in uh, 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 an architecture where you can have a generator that can be used to train the discriminator model as well. So that is face generation part, and facial recognition is where you uh, figure out uh, who the person is, and verification is when you have an existing source of information for a person's face, and then you try to guess if the person that you're seeing in the current image is the same person as before. So these are the three areas that we are going to be focusing on in our demo right now: facial detection, recognition, and verification. So I think convolutional neural networks can be covered by my colleague Raja. Okay, I think he's having some problems. Um, so, so convolutional neural networks are a class of neural networks where you use the convolution operation. The convolution operation is something that can be used as a filter, which can extract different aspects of an image. For example, let's say you see the picture of a cat. One of the convolution matrices will be able to recognize so and so parts from this image of a cat, let's say, and it will be able to combine these extracted features like edges and let's say its nose and so on, and combine it into more complex features, and then be able to infer that it is in fact a cat. Uh, so this is basically the convolutional operation where this is the input feature map which you're providing. This can represent an image, which is a colored image or a black and white image, which has these dimensions. So you can have a kernel which goes over these patches. It slides over it one by one and applies the different kernel transformations on that matrix, and you will be able to get an output feature map, which you can then use to predict an image with certain degree of accuracy. Okay, so the traditional approach to a neural network is to classify a model based on something like the softmax loss. A softmax loss will actually produce an output which directly correlates to the classes on which a neural network is trained on. So let's say you have 1,000 pictures of someone, 1,000 pictures of different people, and uh, a, a, a convolutional neural network trained on the softmax laws will be able to distinguish on the images which are similar to the faces on which you trained on. So you take a picture of me and you take another picture of me, and it will be able to say only if that is a picture, if that is that falls under the class on which it was trained. So what is the thing that we can do to overcome this limitation? So there's this concept of embeddings. An embedding is a low dimensional space on which you can project a high dimensional vector. So what do I mean by this is, let's say you have an RGB image which has 3 channels, and it is of a size 256 into 256. You can get this image and transform it into something that can be expressed as a vector of size, let's say 128. So it's a vector of the dimension 128 can be used to represent that entity in a 128 dimensional hyperspace. So uh, so embeddings can not only be used to train words, as you might know that there was a famous model called Word2Vec sometime back, which came about in 2012. So based on that, we can also apply the same approach to pictures and other forms of data like sound or any kind of data that you can think of. So the primary thing that you need to focus on when you have an embedding is to capture some kind of semantic information. I will explain what this kind of semantic information can do in the following slides. But so if you have such an embedding which represents different entities, let's say different faces in an n-dimensional hypersphere, then you will be able to do operations on it, which will give you some amount of information and relation between these 2 points. So to give you an analogy, let me talk about this image of a simple political compass. Let's say there's a person on the economic left and there's a person on the economic right, and an authoritarian and libertarian government. So people can fall into different categories, right? So if you can see the point of this grid on 2,2, you can say that people between these 2 points are quite similar. And a person who is on this, like the far right authoritarian could be a Nazi, and a person here could be a communist. So different points can mean different things. So and the distance between these 2 points could help you infer some kind of meaning, which is what I meant by semantic relation. So that is what an embedding is, but on a much larger scale. So instead of these 2 dimensions on which I have plotted this, you can have n dimensions like 128, 256, or even 1024. But you'll have to be careful on choosing the amount of dimensions, because you need to focus on your computing resource as well. So what happens when you produce the embeddings from of a person's face, and you need to detect it in a large scale system? If you have a very large vector, you may not be able to do the inferencing accurately within the given time. So let's say you have a video that is streaming, and you need to detect a person's face. You will have to have a very quick response time. So if you have a really large vector size, then it might be difficult to compute all those things in real time. So that is why the current state of the art called Barface uses a teacher-student training model where this embedding space is really lightweight and can be expressed in something like 50 dimensions or so. And that sort of thing can be deployed on edge devices and be used to do real-time inferencing. So that is what an embedding is. But in the paper that we are discussing today, which is FaceNet, uh, uh, we are learning a 128 dimensional embedding, where we are learning the embeddings of images from people's faces, which we are training using the VGG face dataset, which was discussed before. The VGG face dataset contains almost 6,000 faces for training and around 3,000 faces for testing. And the distinguishing part of this FaceNet approach from other approaches is that it learns the embedding as the result of the neural network itself. Instead of having a bottleneck layer before a layer of, let's say, softmax, which you can dissect and obtain the embeddings from the intermediate layers. Here, you optimize it using the end layer itself. So and the resultant vector is around 128 bytes. So how do we do this? So these are some of the key ideas behind the FaceNet paper. So you choose three images. One is an anchor image, one is a positive image, and a negative image. So an anchor image is something that is, looks like this. So this is your anchor image, and then you can have a negative image which is somewhat sorry, a positive image which is somewhat similar to the anchor image, and a negative image which is completely opposite to the anchor image. So these two can be the picture of the same people, and while the negative can be a picture of a completely different person. So you have to mine these triplets from the data set and try to have a data set ready so that it can be used during the training. We will see the code for this in some time. So you have to mind the hard positives and keep these triplets ready. And once you do this, you optimize this neural network to produce embeddings that live on the d-dimensional hypersphere, which so a hypersphere is nothing like but a sphere which you can visualize in 3 dimensions. It's just that it can have many more dimensions. So the radius of this dimension of this hypersphere is going to be 1. So you will see why this is the case when we are demonstrating the code. So this is the architecture. So you send in your batch of faces, and you have any kind of deep neural network architecture. But in this FaceNet model, which was implemented in 2015, they used GoogleNet, which was one of the state-of-the-art machine learning architectures for image recognition at that time. And the final layer was an L2 normalization layer. So L2 normalization is the process by which we can constrain the embeddings to live on this space. So it is nothing but the distance that you learned in high school, which is the square root of x2 minus x1 plus y2 minus y1, right? So that distance is going to be 1 for all the vectors that are being learned by this model. So once you do the constraining part and you produce the embedding, then you train it against the triplet loss. So this is the condition by which we select the triplet, which is the function. So the distance between these embeddings, which is represented by this L2 norm, should be lesser than the distance between the anchor and the negative by a margin alpha. So if you select the triplet like this, then you will be able to optimize it against the loss function like so. So what does F mean here? The F is nothing but the neural network. So if to describe a neural network in very simplistic terms, it is a function. It is a very flexible function, which you can use to model almost any function with very good approximation. Let's say you have the equation of parabola, you can model it using neural network. So this function is what we are trying to learn using the neural network. So this function's requirements are that it reduce this loss function, which actually makes the neural network produce embeddings such that the positives are closer to the anchor than the negatives. And so that was the triplet loss function. So you will have to choose your triplets also carefully, and there's also many nuances in the paper about how to train your neural network. So you will have to first pick soft negatives and then pick your hard negatives. So this is done to prevent the collapse of the model. So these are all various considerations that they took while training their model in 2016. So let's go over to the implementation part. Okay. So the VGG face dataset contains an image dataset with all these people. So the Dalai Lama is one of the people that are there in the VGG face dataset. So we can use this information to predict who later on in the code. But the crucial part here is the triplet selection. So you have a training list of images which belong to a certain class and a testing list. So you select you generate the triplets using this approach. You randomly sample two images for the anchor and positive from across the training set, and then you choose a negative, which is that of a different person. So once you generate this a triplet like this, you will be able to visualize it like this. So this is a training batch of 4, where you can see that this set corresponds to a triplet, where these two are the pictures of the same person but different pictures. Well, this is an entirely different person, and similarly for the other faces also. So once you have triplets like this, you can go over, you can generate a lot of permutations from among the 6,000 training images that are at your disposal. For the purposes of this session, we produced triplets of around only 10,000 because of our computational constraints. But we were able to achieve a modest amount of accuracy with this as well. So one of the first things that you should do when you're detecting faces is to do alignment. You have to detect the face which is there in the image, and you'll have to remove out the irrelevant details. So this is one approach, which is what we did in this project. But there's also another thing called image segmentation, which is what you see when I am presenting on the Zoom, like, and you're able to see a different background while my face is segmented correctly. So that is image segmentation. You can also do that, and this helps you narrow down the details that the neural network has to process. So this our implementation is in PyTorch. So PyTorch provides you with a way to abstract away the dataset, and this will be a generator which you can use to iterate through, and you can specify a lot of things like how many batches do you want on your image, and how many workers do you want sending all this to manage all the parallelization stuff. These are all abstracted away by PyTorch, and we are getting the information about these triplets from the CSV that we just generated. And there's some data cleaning to provide a default triplet in case there is some corrupted image inside the dataset. And this brings us to our model, which is a flexible thing where you provide a base model. This could be any state-of-the-art model which is trained on an image recognition dataset, like let's say um, um, GoogleNet or ResNet or ResNet Inception, and, or even the latest state-of-the-art uh, uh, is a network which is produced by Google. But the thing that you need to worry about when selecting this base model is the amount of computational power that you have, and how much parameters you will need to you will have capacity for. For example, let's say you're running a model on a Raspberry Pi. You will need a very lightweight model. In that case, you can go for something like a mobile version of neural networks, which are already available. But in this case, we are going with the ResNet model, which was a paper that came sometime back in 2017 as well. So that is our base model, and we have some boilerplate code which is about adapting adapt average pooling of the final layer, and then we directly train the dimensions that we need in the final layer. So usually, what you will see in convolutional neural networks is a final layer which is followed by a softmax layer. So the softmax layer actually just provides the probabilities of fixed classes that on which the network was trained. But here, you what you do is train the 128 dimensions that are necessary for the neural network directly. So finally, what you do after applying these functions one over the other is the normalization part, which is the L2 part that you saw in the architecture. As I said, this is the distance of the embedding from the origin. We are constraining that to normalizing to a normalized value, which is going to be of radius 1. The reason for this is to produce embeddings to, let's say, to reduce the noise of the model. Let's say you have uh, a vector which is pointing in a particular place, and a vector which is just a scaled form of that vector. So these two vectors may represent the same thing, but if they are not constrained to that hypersphere, then it might affect the distance unnecessarily. So that is the whole purpose of this normalization layer, so that you can have a hypersphere on which you can uh, 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 you can represent it meaningfully. The other thing is once we are normalizing it, we are again multiplying it by a fixed factor of 10. This is done so that we have a bigger slice. Let's say, if you let's say you have a sphere of radius 1, that surface area is going to be a little bit smaller, right? Although it is infinite dimensional. Uh, uh, if you multiply it by a factor of 10, then you have a bigger surface area in which you can represent even more images. And it helps you provide more uh, uh, bigger margins than what you would have done uh, with a unit radius sphere. Uh, So this is the description for model, and let's move over to the training process. So this is the training data loader which we saw before, and we are sampling. We are getting the images from the loader, which provides us in batches of. Here in this code, we have used a batch of 2 because we are training on CPU and not on GPU. But ideally, if you have a GPU, you would be training with like 64 images in a batch. So moving on. So you calculate the embedding of the anchor image, positive image, and the negative image. And then you find the L2 distance, which what I mentioned before as the Euclidean distance, which you learned in high school, which just gives the distance between 2 points. So once you measure these two distances, you can generate the matrix, which is giving you the information about which uh, which images inside the batch are exceeding the or are within the margin, right? So if you produce a matrix like that, then this is going to be a true or false vector here, right? So using the NumPy library, you could select the hard triplets from the anchor embeddings. So these are the embeddings which actually had a had this particular function as more than what is required by the loss function. So once we select these hard triplets, then we go over to the triplet loss. We evaluate the loss based on the same formula which we saw before. So this is nothing but, so this is the embedding and this is the embedding, which is then and then we apply a ReLU function on it, which makes it positive. So this is the loss function. And you do some kind of optimization algorithm on it. So you can use stochastic gradient descent, ADAM, or whichever optimizer is suitable. And in this project, we have used the ADAM optimizer. So you can record your average training loss in an epoch and measure the testing loss. And once the training is done, then you will be able to produce. So what you're seeing here is nothing but the number of layers on this network. So then you'll be able to measure the distance. So what the neural network produces is a scalar like this. So once you have the embedding which is produced by the model, you can measure the distance, which says that the distance between these two images is going to be lesser than the distance between these two images, which are obviously of different people, as you can see here. So this is something that we trained on a limited data set of 10,000 triplets. If you have more, then you would be able to fine-grain the training process and make them even closer. So we used a pre-trained model which was trained on like 10,000 images, 10,000 triplets, which comes down to 100,000 triplets, which comes down to 300,000 images in total. And as you can see, the same training process and everything. If you have a bigger data set, you can reduce the distance by so and so. And still again, you have a wider margin between these two images. So how do you use this for detecting a face? Let's say you have so this project is what we did is primarily as part of a thing where we can it's usually it was done for a gate pass kind of a project. So where if you just enter into our office, you will be able to enter without your key pass or something. So that was the idea behind this. So you have an image which is presented by the employee, let's say, and then you walk into the door, and you figure out a margin within which you will allow the person inside. So if you have a person whose embedding is stored in your database, and then you apply the model on the incoming image of the person, you'll be able to figure out the distance between these two images and basically say that this is the same person, and you will let them in. So this is how a facial recognition model is built. Let's say you want to run this at scale. You have to prune the model for running on edge devices. So you can let's say transform this model to a C++ implementation, or you can obtain something called an ONNX runtime, which can help you run the same model on different devices. So it will scale down to the level of hardware that you're finally going to use. Uh, so, so yeah, as you can see, this is something uh, unique to the FaceNet approach, uh, which is uh, so the unique part of this FaceNet approach is that unlike the other CNN network, which had a fixed amount of classes on which you can train, you have an embedding space in which you can basically put anyone into the DB by submitting an anchor image and storing them in your database without having to retrain the model again and again. So you have what you have done is just create a function which is uh, which generalizes very well to a lot of people. It almost distills down to something that will represent a face of a person, like what your brain does intuitively. So it provides a very general model upon which you can build upon and productionize this as you like. So that's the
So as Jeremy was saying about the attendance part, like basically recognizing the person, we also thought we can show you a demo of how that would look like. So I'll try to share screen with that. Sorry for the initial hiccups. I don't know, like my machine gave. So I'll first run it and then explain what how it works. I mean, pretty much it's the same FaceNet model which we discussed all along. So yeah. So yeah. So it's not like perfectly accurate. So right now, if you could see, it recognizes me as Raja, but if I slightly move somewhere, it's like not that accurate. So sometimes it says new. So basically, it's been doing well so far, but if I just move somewhere, the face detection itself is gone. Even it doesn't recognize the face, whereas when I squint, possibly it says it's new. So basically what this model tries to do is, on a pausing video frame, it first tries to identify what is the face and then tries to identify the embedding for that particular face and compares it with the already existing embedding. And if that embedding is within a particular range, it says both are same. If not, it says this is a new person. And right now, the only embedding I have given to this model is myself. So it either says it's Raja or it says it's somebody new. So let's quickly take a look over the code. This is pretty much the video capture stuff which you have in the Pillow library and the OpenCV libraries. So the interesting thing is the model which we are using, which is Inception ResNet, which is trained again on VGG phase 2. Jeremy gave a detailed explanation of how we actually try to build it up and improve an accuracy, but here I'm showing it with an existing pre-trained model. So the aspect of that is we train the model, and then actually first, before that, we have to capture the particular face, whether we have to recognize first whether there's a person coming in this particular image or not. So that's where the aspect of that is coming from MTCNN, which actually detects whether there's a face in the video frame. So if so, it tries to draw a bounding box around that face. So that's pretty much what it gives. So once we get that, we pass that particular cropped area. We pass that particular cropped area to our model. So that's the pre-processing step which happens. So when I call this model.getEmbedding, it actually runs through a preprocessor where we align the image, we resize the image to 160 pixel, and then we normalize it, which is typically what the steps which Jeremy discussed in the previous section. So we take an image, we take the entire video frame, first try to identify where the face is, identify that, then try to crop it to a 160 by 160 pixel, and then use it to get the embeddings. We discussed about how we get the embeddings. Once we do get the embeddings, we use that to compare it with an existing embedding, which is what I have here. So I'm just trying to run the entire process actually on this image, and then I'm getting the anchor embedding. So I do compare with the generated embedding and the anchor embedding to see if the distance is within the range. And if that is within the range, I say this is Raja, since that's the only image we have here. If not, it will say it's a new person. Then on the original video stream, we do put back saying like we have identified this particular person. So one of the cool use cases we were trying to think of this for our office was also to capture people like welcoming, like, okay, these are the people coming. So we were with that motivation we started, and we were using FaceNet as one of our papers to implement this. So that's pretty much what I wanted to share as part of this particular demo.
Okay. Raja, there's a question from Venkatraman. Does the final accuracy depends on the base model we use? Which base model would you give us for the best accuracy? Would you like to answer?
Sorry. So you can basically use any state-of-the-art model which is being used for training on ImageNet, right? So that gives you have a variety of options. You can either use a complex model, which gives you the highest accuracy, but the trade-off that you'll have to make here is cost, where you'll have to have let's say a supercomputer if you're going to search criminal databases. So you'll need to have more computing. If you have more computing power, then you can obviously use the most complex model there is, which will give you the highest accuracy. But if you're going to be deploying on an edge device, like let's say a Raspberry Pi, then you will have to make the model smaller. So which is what the VAR-phase model does, where they have a complex model which trains a student network, which reduces the number of parameters that need to be trained. And so you can deploy that student model, which has reduced parameters, onto the Raspberry Pi. So it's never the best accuracy. That's not the whole question. It's the best accuracy given the computing power that you have. So you can decide based on whichever platform that you're going to deploy it on. Any other questions? Okay. Can we move to the next session?
If there are no questions left, we can move on.
Maybe we'll wait for like 5 more minutes and we can. We have a question from YouTube. Jasu has asked it. I'll post it in chat. Jamie, Raja, able to see the question in the chat screen?
I can see the question. So, as I said before, it depends on where you want to deploy your model. Let's say, let me take the example of Amazon's facial recognition product. So it's not like uh, something that they give out for free. Of course, there are open source models that you can use, but an actual system where you have your own needs. Let's say you only need to train, recognize 100 faces. So the solutions that are provided by companies like Google and Amazon are meant for a large scale audience, which may not be very cost effective for you. So if you want to limit your cost, then you can build your own model. And obviously, you can use transfer learning if you want to, by importing another model and fine tuning it on your data set. The advantage here is, let's say they have a data set which is trained on people like people from Hollywood, let's say, which is not a very diverse crowd, as everyone can agree. So the model might be biased towards people of color. So what you can do is, if you have let's say more people of color in your organization, then you can train your model better on that data set, and you can basically customize it to your solution space. So this is what you need, and uh, it's actually a choice that you'll have to make. So while the companies provide implementations which are more for a generic audience, you can optimize it for two reasons. One is cost, and the other is the population on which you are going to deploy this model. So that could be a reason why you can create a facial recognition model from scratch.
Okay, I think that's all we have. Okay, so thank you, Jeremy and Raja, for sharing your knowledge on the facial recognition. I'm sure
everyone found it very useful and would like to try them. So folks, let's take a 10 minutes break, and in the meantime we'll be sharing a feedback form, yeah, and we would be really grateful if you can fill that. Thank you. See you after 10 minutes. Welcome back, folks. So we are here for the second talk of the session. So Sarath from EITB Global Info Solutions is here with us to talk about Deno and the possibilities of it replacing Node.js. So over to you, Sharath. Good luck.
Thank you, Samyukta. Are you guys able to see my screen?
Yes, sir, it's visible.
Yeah, thank you. Hello, everyone. Hope you all guys doing good in the quarantine. Myself, Sarath. I'm a full stack developer at EITB Global Info Solution. And today we can talk about what is Deno and will it replace Node.js. 1 month back, I was checking my Twitter and scrolling down what is going on, and started to popping some kind of things like what is Deno and will it Node.js dies, and I was kind of shocked. And some of the popular memes are getting popped up in my timeline saying, is Deno is secure and fast, lightweight, and better than Node? And even some people have started asking, will Deno replace Node? As a JavaScript developer, I was using a Node.js for past 3.5 years and felt quite insecure myself and started to think, what is it? Why people are talking more about these things? Because as a JavaScript developer, every day there is a new framework introduced in JavaScript. That's not a new thing, but people are going so crazy about this thing. So it gained my attention to check out what exactly is Deno. And when I checked in the GitHub, it already gained 60,000 plus stars in the GitHub, which is quite great achievement because which is larger than the AngularJS, because AngularJS there for more than 5 years in the industry, but within 40 days, the Deno gained 64,000 stars in the GitHub, which is very amazing. Why it's become so popular among the JavaScript developer? Because when I checking this, I found which is created by same developer who created Node.js called Randall, and that's the reason people are going crazy. The creator itself thought to replace Node.js, by introducing a new framework or a new runtime in the server. So I'm also curious to learn what exactly this. Then I went and researched and got some news. So today talk is what is Deno, a quick introduction about that, and we can talk further whether it's going to replace the Node.js or not in the coming slides. So without any delay, we can just start. So what is Deno? This is a description I found in the GitHub, a secure runtime for JavaScript and TypeScript, which is quite simple because Node.js is also a server runtime for JavaScript. So what is the difference between Node and Deno? The Deno allows execute JavaScript outside the web browser. That's what exactly Node does. So, and also it uses the same code which Node using a V8 JavaScript engine, which is powered by many of our popular browsers like Chrome, and even the Microsoft recently adopted the V8 engine to give the seamless experience to users. And Deno is originally prototyped in Golang, then it's created in the Rust, because Rust getting more popularity recent these days, because even the Microsoft decided to go rewrite some of their popular applications from C++ to Rust because of the memory issues and memory management things. So we can talk about how the internal design is designed in Deno. The Randall recently shared the screen with recent OpenJS conference, which is held in the internet a couple of days ago. He shared like it is inspired by Linux the same way it is designed. For example, Linux uses the process for the background working, and it's called web workers, and the communication between OS and the process is called syscalls in the Linux, which is OPS in Deno. And file descriptor, here it's called resource IDs, and you can see the below picture, V8 written in C++, which is a wrapper around the Deno core, which runs the Deno codes in the server, which is very similar to the Linux. And we can talk about what are the features, which is very different from the Node.js. What makes it so different? It's secure by default, no file, network, or environmental access unless we explicitly enable it. For example, what exactly is this? For example, when we downloading a package from npm, we don't know whether it's access our file system or network ports and environment variables. Let's say we have a environment variables like a no GitHub gist saved in the environment variable, which can directly access by some kind of a code written in the JavaScript when we are downloading from npm, which is not good, because without our knowledge, it taking all the available things in our OS, it can access all of the things which is in the server, which is not good. So Deno has come up with a security thing called they cannot access those things unless we explicitly enable it, because we want to know what exactly this script is going to use. For example, when we are using a Android mobile, we will know when you're installing an application, it will pop up the permissions like this is going to access your camera, this is going to access your location data. So the same way, the Deno done the same thing in the core by default. You don't have to write any custom modules and any custom codes. So which is very great things. And also it supports the TypeScript out of the box. TypeScript is very popular among JavaScript developers. Or one of the popular developer environment like VS Code written in TypeScript by Microsoft. So when you want to use the TypeScript in Node.js, you have to install it by npm, and you have to configure, you have to compile it, then only you can use it as a JavaScript thing. But in Deno, by default, it's support TypeScript out of the box, which is very great things. And also it ships only a single executable file, which is very, very great thing, because when you're sharing a Node.js application, a small application, not even a simple hello world application to someone else, you need to share npm modules folder, package.json, then only they can run that code. And the entry file also, for example, it can be main.js or index.js. And one more breakthrough change is no more npm, no modules folder, node modules folder, and package.json. Everything is removed from the Node.js. That means in this system, we can expect those things, because a couple of years back, Brian Dolch shared a few things in the JS conference. Europe said that 10 things he regret about Node.js. So he wanted to remove those problems from Node.js and design a better than Node.js. So that's the reason he come up with the idea. He's worked a couple of years and come up with the denojs. And Deno is a browser for command line script, which means Deno makes a programming easy by letting you import and run code straight from the internet. We may think, why? We can import a script directly from the internet. Many of us think it's quite dangerous. We don't know what exactly it comes from the internet when we talk about. But the thing is, which is same thing happening in the npm also, and the same thing happening when we're calling a JavaScript code in our websites. It's coming from the server. So that's the reason they gave us default security options to stop accessing your file system, network, and other things. Deno is a secure sandbox which can optionally reach into the OS when you give him permissions. Now we can see few demos how we can run the Deno in our systems. For example, when we check the Deno website, there are some examples. So we can go and choose something like welcome.script. I'm copying this URL since it can directly run the TypeScript in our PowerShell or our command line. It's Deno run the URL. Since I already downloaded it in my screen, so it's just compiling into a executable and giving the results. You can see. And also you may think how it will work when we don't have the internet. It will take the cache in your system. It will compile it into a JavaScript file, so you don't have to do it multiple times. Since I'm already downloaded this, that's the reason it's not downloading again. So it's saved in the cache in your system, so you can reuse it again. For example, we can run a few more examples like this one. This code does, it will get the environment variable in your system and print it. That's the only thing it will do. So let's try run this. Here you can see it's giving an error. Uncaught permission denied. Access to the environment variable. Run again with allow environment flag. So here we can see it's not allowing that script access our environment variable. So that's the reason it's very secure. And that now I know this script is accessing my Okay, am I audible to everybody?
Yes, sir, you're audible.
Yeah, sorry about the interruption. So by default, it's not allowing nobody's to access our environment variable. There you can see it's giving an error. So let's run again with allowing environment variable. Run -. Same script. So it's given the GIST token environment variable is not set, and that means it's trying to get the GIST token, which is I didn't set anything. So that's the reason it's giving is not variable set. That means it's accessed my environment variable. So by default, we have to keep the option to access our things. And also I can show some more things like a server in Node.js is very easy to start a server. Like we can use HTTP module import and just listen to the port. It will start a new server. That's it. And here also same. And here you can say it's giving error for it trying to access the network. So I'm going to give the access. Allow net space and run it again. So it's now a server is created. We can access it by See, it's a React page. A single executable file will give all the power in the React. Here you can see it's a React application by checking our developer tools components. The state is changing when I'm clicking this. And also we can see how the files are downloaded. What are the dependencies for the particular script you're downloading? If you want to know that, you can simply type Deno info and the script name. It will give you all of the dependencies and where they are stored and everything. You can see it in the screen. And there are a few more things called unstable. We can run the unstable, means the ongoing in development plugins. Also we can run it in the Deno by using a flag called unstable. I'm not going to run it now. And Deno is also come up with a few tools for formatting and show the documentations and linting process. I can show one documentation example for you. For example, let's say I'm taking this and doc. Here you can see it will pull the documentation from the server and display it in your PowerShell script. And you can see the documentation for listen and serve, TLS, and some of the methods available, response, HTTP options, and so on. Those kind of tools which is available by default. In Node.js you have to download the different libraries to achieve these things. For example, if you want to format, you have to use a beautifier and many things, so which is already available by default in Deno. And in his talk, Ren told there are told what is the reason, what is the future work for Denojs, and what exactly is planned for doing it, making it great. And then the Node.js, he said, is going to create a OP creates, which means you can use a small portion of Deno core code and embed it into a different programming language like Rust and Python and any other languages. You can use a certain part of JavaScript code in any other server level languages, which is very great. And using a GPU APIs, web GPU to support machine language and learning applications. For example, to use more GPU level things. And Deno compile a feature that compiles JS into binary executable. That means you can install JavaScript code by using a .exe file or different executable file for Mac and Linux. You can directly run JavaScript by installing it, which is very great. And currently for Node.js, it's doing it by, for example, Electron.js is doing the same. You can, while you are creating a GUI application for your Windows OS, it will create a binary executable. But here they are planning to do it by core level. So it is easy to create a GUI application to everybody can create a executable files and distribute with others. And the final thing is, will Node.js die? Before that, we need to talk about a little bit about Node.js also, because Node.js brought JavaScript to the server, which is very, very great thing for our JavaScript developers, because when I started a career, I worked in a PHP developer, and also I'm very much interested in JavaScript. I used to work for JavaScript for front end and the PHP for the backend. So I used to write many codes differently. So, different windows, and I even write some syntax errors in my code, because I was more into JavaScript code. When I'm writing a PHP, I'm getting more syntax errors. But after I'm started to learn about Node.js, I can write the same code in server level and the front end level also. So which is very great thing, because you can share the same code, reuse the same code in the server level and the front end level, which is very great thing. And Node.js is a PHP of 2010s, because PHP is very popular now. Everybody, most of the people are using PHP. So Node.js become very threat to the PHP, because the performance of Node.js is very, very high than the PHP. So everybody started to using it, and most of the cloud vendors like AWS, Google, Azure supporting Node.js, so which allows all the developers to write Node.js code in the server level and the front side also. And one way or another, all front-end frameworks use Node.js bundle to bundle the front-end code. For example, React, Vue, Angular, everything is using a Node.js to bundle their code. So, which makes essentially every website uses Node in one form or another. So that's the reason is Node becomes so popular, and everybody started using it. And suddenly some new things introduced recently, and people have started to think. I was learning about Node.js, started to using, and I even started using it in my production servers. And should I rewrite? Those things are questions popping out because of the buzz created by the Deno. But in my opinion, I don't think the Deno is going to replace Node.js, because Node.js created for the different purpose, and Deno is created for the different purpose. And even the Deno is supporting other things which is present in the Node.js, and also it's giving more secure and different features, but still Node.js will stay forever. For example, Deno is released 1 month back, and the bugs are getting pops up every day, and they're fixing it. Within 1 month they released 12 versions within 40 days, that means there are more bugs in the Deno, and those need to get fixed, and it will take some time to gain a market in the server level JavaScript things, because Node.js is very much matured. It is there for more than 11 years. I don't think something came in 1 month back and it will going to replace. I don't think it's possible, and nobody should get panicked because of that. And a few more things. During after Node.js came out, there was a lot of things that changed in the JavaScript ecosystems, like array buffer, synth wait, ES modules, and WebAssembly and TypeScripts. One of the best things in Deno is it support all of these things out of the box. For example, if you want to use async or await in the Node.js, you can use those things only in the async function. Without that, you can't use await or things. And most of the ES modules are still in the development level in Node.js, which is not in the production level. For example, as a React developer, you can use the import syntax for importing library files, but you can't use the same in Node.js. You have to use a require, which is a little bit different, because Node.js is not adopted all of the ES modules changes. and they're still doing it. And WebAssembly things and TypeScript, in my opinion, they can merge some of the popular scripts, popular things available in the internet, more stable things. You can merge it to the Node.js core, which allows developer to use more things easily in the Node.js, because it's gained that much popularity and everybody using it. They don't have to install something different to support these things. So that's my opinion. But still, Node.js is going to be there for at least 10 years in my opinions. And Deno, you can, as a tech enthusiast, you can start play around with the Deno, but definitely that's not going to replace. And also it's written to support something different and different meaning for, like, embedding into other programming language, into more core level, server level things than the Node.js. So it's both are not in the same area to compete with each other. So in my opinion, it's not going to replace anything. Hope you guys all got the things what I'm trying to say. And if you have any question, you can ask me.
Sarath, we do have one question in the QA box.
Yeah.
Present is asking, what is the advantage of using Deno?
What is the advantage of
using Deno?
Yeah, that's the thing I told in the initial stages. It is supporting. It's more secure than the Node.js. That doesn't mean Node.js is not secure. That means if you want to secure the Node.js, you have to write some custom modules, custom script to make it more secure. But in Deno, it's by default, it's more secure. That means without your permission, nothing can be accessed, like in the Android phones. Let's say application you're installing that's going to access your camera, you can decide whether it can access your camera or not. So that gives more power to you, what exactly that script uses. And also the TypeScript, it gives the native option to run all of the TypeScript things. And one more thing I saw, GitHub setting when you give permission. What was that? I'm not getting the question, but saw some GitHub setting when you give permission. What was that? Actually, when you write, actually I didn't say anything in the GitHub. Actually, I was setting in the.
We can probably allow that person to ask the question directly if it's not clear to you.
Yeah. Hi, Prasantas. A question about.
Prashant,
Yeah.
Hello.
Yeah, hi, Prashant.
Hi. Yeah, it was a nice session. So during some permission, you gave the force permission something in the command line. That time I'm able to see there is some GitHub settings.
Okay. That's not the GitHub settings. It actually Deno's settings. For example, when you're running a script, since Deno is running a script directly from the internet, we need to know whether it needs some kind of permissions. So when you're running it, it is going to pop up some errors. Like,
yeah, could you show me the command line once again?
I'm running this again. Let's say I'm running a simple server script, which is directly taken from the Deno server. While I'm running this, it's giving an error called network access to these things. That means there is no permission to run the script. The script doesn't have any permission to access my network, because since it's a server code, it should have the network access. Then only it can start to listening the port 80. So that's the reason I'm going to give the permission allow net space, the same code. And now you can see the server is running on port 3000. So it start listening. So we are initially giving permission to access my network to that script. And so that's the reason it's very different from the Node.js, and not only for the network, it's for the file read and write permissions and environment variables and many things. One more things I can. And somebody asked about whether it's going to run only TypeScript or no JavaScript questions. Actually, you can use both TypeScript and JavaScript. The behind the scene, when you're running a TypeScript, it actually compiles into JavaScript, and the JavaScript code will be run at the time of we are running the code. So obviously it means you can run JavaScript by default and TypeScript also. If you're a TypeScript developer, you can directly write a TypeScript. It is get compiled into JavaScript, and it will execute it in the code. No, it's not recommended. It's not default. You should write a TypeScript. You can write a JavaScript by default. You don't have to worry about should I use TypeScript. TypeScript just additional things which you can use it, but that doesn't mean you have to use exactly TypeScript only in Deno. That's optional things we can use or not. That's entirely your decision. For example, you can see my screen. When I run the code, it actually, the TypeScript code is compiled into JavaScript code, which is saved in your local system. For example, in my case, it is Denoland standard library and examples. You can see whatever the code I ran, it is compiled into JS file. So it's not necessary. You should, there's no settings you should write a TypeScript only. You can use JavaScript by default, but at the same time it's giving one more option. You can use the TypeScript also without any configuration. That's one of the options. Any questions?
Sarath, we do have a few questions from the YouTube.
Yeah.
Look into the chat box. It is from Jaisurya and Macropon. First one.
You'll be able to find the chat box in the share screen window.
Yeah. For starting a new project, what we did, Deno, stay with the Node.js. Take more years to match the progress. For the Jaisurya question, for starting a new project right now, what would you choose, Deno or stay with Node? In my opinion, I'll definitely stay with Node because within 40 days, it really, within 40 days, there are total releases for the Deno. Why I'm saying this, it's getting a lot of bugs, and I don't think it's ready for the productions. Even though it's released a 1.0 version, but still it's not ready for the production version, and nobody knows what exactly will happen when you're using it in large productions. And also, one of the best things for the JavaScript developers, when you're writing a code, developing a new application, you can directly, when you facing any kind of issues, you directly go to the Stack Overflow and other developer forums and search for the new things. And especially for the Nodejs also, there are a lot of questions, a lot of helps you can get it from the developer forums. But for the Deno, I don't think that much questions and that much help is available in the internet, because everybody, every tutorial writers and tech enthusiasts started to writing tutorials for Deno. Now this is the period everybody started to play around to see what exactly is there. So in my opinion, it's not recommended for a serious project. And Marco Palli is asked, hard to consider new 2008. Okay, first question. And Marco Palli, from the question of the Marco Palli, I can see he hate NPM, and most of the people hate NPM also. Even the Ryan dolls said the same thing, because it has a lot of, I can even saw in the internet some kind of memes like heaviest object in the universe is like NPM, because it has a lot of things. When you just downloading React, it will download at least 100 dependencies, not directly, from indirectly. More than 100 folders in your known modules folder. It's hard to ship it and see what exactly going behind. So that's the reason they thought they wanted to remove NPM from the thing, from the game. And also when you're writing a Node.js, you need to know NPM init. It will ask you some dumbest questions which you don't want to answer, like who's the other GitHub repository name, entry point, XYZ, and more questions. We can avoid that. And one more thing, some people is also stated that he hate TypeScript with Node.js, and definitely TypeScript have more advantages which you can utilize it in Node.js and Deno also. But the only difference is when you're using a Node.js TypeScript in Node.js, you have to install it by npm and configure it and compile it. The compiling part can be done background, but you need to do the same things in Node.js. But in Deno, you don't have to care about any of those things. Just write a TypeScript thing and it will run. That's it. It will get compiled into JavaScript code. And also don't get confused. The Deno is going to only use TypeScript. TypeScript is one of the advantages. That's not the only thing you have to use it. That's the thing. Any other questions?
Hello.
Yeah, hi.
Yeah, hi. So since you said there's no npm or packages of JSON, how does Deno replace that work? I mean that part.
Yeah, there you can see it's already done by their command line thing itself. You can directly run script from the internet.
Okay,
so
the internet
while downloading itself, it will install all the dependencies and it will compile it into JavaScript. If it is written in TypeScript, it will get compiled. If it is written in JavaScript, there is no need for compilation. It will directly run in the which is taken care by Deno itself. You don't have to use one more things. For example, in the Node, you use Node for running an application. You use npm for managing your packages, and npm has a lot of cool features also. I'm not going to deny it. It has audit features and donation features they're bringing now, but I don't know those things are exist exactly. Those things are exist in Deno, but the thing is they thought they don't want to use npm anymore. They want to replace it with their console things. They're going to use a native Deno command line tool to replace npm, so we don't have to use any external things. That's the thing. And at this time we don't know the Deno is providing all the options which is provided by the npm, because npm is also there for more than 10 years. So it's very much matured and it's provide a lot of options, and we can't expect Deno is going to provide all these features at this moment. But the only thing is we can expect the current things they are going to replace. That's the decision they took, but we can't expect all the things it will, all the features it will be available in the Deno right now itself. So it's kind of a very early stage, but the only thing is it's gained a lot of popularity more than anything. It got 64,000 stars, which is not easy. Even the AngularJS for long time there, which has a 62,000. So you can see how much popularity gained within a 1 month of period. So that's the reason everybody started to think, they are confusing themselves whether it is going to replace Node. It's not going to replace it. That's a that's the main task, main goal of this talk. I wanted to explain what are the new features, whether we can use it, which is welcome. The features proposed in the Deno is very good, and it's a different, and those things we wanted for the JavaScript developer. And when we're thinking of replacing with other technology, currently that's not possible. We can play around to, know more. You can contribute to community and make it better. In the coming days, it can be a game changer for JavaScript developers, definitely. And in my opinion, it can be a competitor for other languages. I don't think for Node.js.
Okay, thank you.
Thank you. Any other question?
Okay, I think. Okay, I think that's all the questions we had.
Yeah, and thank you for the opportunity to share my session with you guys, and thanks for the Thoughtworks to giving the opportunity to present my session. And thank you. Have a great night, everybody. Thank you.
Yeah, thank you, Sarath. Thank you for sharing your knowledge about Deno. I'm sure it's something new for most of us here. And yeah, and thank you all. Thank you for your time and attending the session here. We would again share the feedback form here. It would be really good if you can spend few minutes filling up the form. And yeah, we've come to the end of the session. Thanks again and have a good night. See you all in the next session. Bye.